right, here's your quick video for lesson 17.1. So what we're doing here is we are going through factoring again because the title of the section is algebraic methods. So we're talking about algebraic ways that we can solve eventually. We're not going to solve in this section here, but how can we find the solutions for a polynomial when its degree is higher than 2. Now, some polynomials are degree 2, and we've already talked about how to solve those. So when you have a quadratic or a second degree polynomial, you have multiple choices for how you can solve it. You could solve it by factoring possibly, or you might have to complete the square or use the quadratic formula. But once we move up to higher order polynomials, when we are going to solve completely algebraically, we can't use the quadratic formula, and we can't use completing the square. Those only work for quadratics. Factoring does work for some higher order polynomials, of course not for all of them. So when we have ones that don't factor, we'll have to save that for a totally separate section because we have to deal with those completely differently. So what I've written up here are the similar things to what we went through when we talked in section 7.2 about factoring originally. Remember, every factoring problem, this is an order of operations. You look for GCFs first, then you look for special products, then you chart factor, then you would factor by grouping. So the two things that we're adding in new for this section are sum and difference of cubes, which is completely new. You have not learned how to do those. Grouping, I'm kind of going to say is new. We've talked about how to factor by grouping, but you haven't had to factor by grouping, which you will have to in this lesson. So we will review that as well. So what we're going to look at is just a couple examples. The first example I'm going to do here is you're going to be on page 268, and this is try these be. And we did part B in class, those of you who are in class, so we're going to look at part A. Here on the video. So directions say to factor by grouping, and you've got 2x cubed plus 10x squared minus 3x minus 15. So when you factor by grouping, the first step is to group the first two terms together and then group the second two terms together. Factoring by grouping we use when there are 4 terms, so it's always first two and then second two. The book uses parentheses. I discourage parentheses because then people think it's factored or then think that the problem was to subtract or to add, which it's not. So I use these little brackets to prevent that misconception. Once you've grouped them, then all we're going to do is really go back to GCF factoring. We're going to find the GCF of both groups. So these first two terms, they're both divisible by 2. They both also have at least an x squared. So 2x squared is my GCF. So I pull the GCF out in front. And then remember what I'm doing when I take it out is I'm reverse distributing. So it's like dividing. What do I multiply 2x squared by to get 2x cubed? We did that when we did polynomial long division. So the answer is x. So I write x. Then what do I multiply 2x squared by to get 10x squared? That would be 5. So I write plus 5. Then I'm going to find the GCF of my second group. So they're both divisible by 3. They don't both have an x. So many people might look at that and say 3. Now, the thing about factoring by grouping, and we did cover this part already, for those of you who like to factor using the split the middle for your chart factoring, because we already talked about the fact that when you factor by grouping, the parentheses have to match. If you just make this a 3, this in here, this first term, would be a negative x, and it has to match. So it needs to be a positive x, which tells you that the GCF should be negative 3. So what do I multiply negative 3 by to get negative 3x? I multiply by x. What do I multiply negative 3 by to get negative 15? I multiply by positive 5. So I've confirmed that GCF is appropriate, and I have my two parentheses that match. Final step is to write it in factored form, which should include two parentheses. The first one is what I call the leftovers. It's the numbers that were out in front, those GCFs there. And the second one is the parenthesis that they had in common. So our factorization, our final answer is 2x squared minus 3 times x plus 5. Now remember that you always have to check to see if something factors further. These don't, because linear terms aren't going to factor further other than GCF, and this doesn't have a GCF. Quadratic, when I look at this is a binomial. So if it were going to factor further, the only way it could do so is with GCF, which there is none, or a difference of squares, which they don't have perfect square roots. So this does not factor further. That is our final answer. All right, so that takes care of grouping. Now I want to look at sum and difference of cubes. Now, what I wrote, for those of you who got to see it in class, on the board was kind of the pattern. So now we're on page 269, kind of in the middle. In the margin, I want to make sure that you write this out. It says right on your book, a difference of two squares can be factored by using a specific pattern, and then it reviews that. Then it says a difference of two cubes and a sum of two cubes also have a factoring pattern. And they show you they show you a cubed minus b cubed and what it factors into, which is this. And then they also show a cubed plus b cubed in there. You don't have to write this, it's already in your book, which is a plus b times a squared minus ab plus b squared. Now, what I want you to write in the margin is the pattern that is always true, because I don't want you to get caught up in the a's and b's necessarily. One thing that's always true is that a sum and difference of cubes factors into a binomial times a trinomial. So, binomial, trinomial, binomial, trinomial. Your original is a binomial. They're both are perfect cubes, meaning they both have perfect cube roots. So binomial times a trinomial. These do both have perfect cube roots because the cube root of a cubed is a. The cube root of b cubed is b. So it's a binomial times a trinomial when we factor it. Specifically, the binomial, the first term, you just take the cube root of the first term of the original. Then you're going to put the sign. It'll either be a plus or a minus. This is going to be the same as the original sign. Then you're going to have cube root of the second term of the binomial, or the last term, however you want to write it. Since your original only had two, the cube root of that is what goes second. So you can see that holds true here. The cube root of a cubed is a. The cube root of b cubed is b. Now, for the trinomial, this is different than the other special product factoring where, it kind of followed a different type of pattern. When you factor and write the trinomial part, you actually don't look back at the original at all. You only look at this part that you've already done. So you've already done cube root of the first, your sign, and then cube root of the second. What you do for the second part is that you square the cube root of the first. So I don't care whether you write it out in words, square first term of the binomial, and know that it means this one, or if it makes more sense to you to actually write cube root of the first squared, they're the same thing, so I don't care. Then you need a sign. This one is going to be opposite of the original, so whatever you put here it'll be the opposite sign. So notice this was a minus, this is a plus, this was a plus, this is a minus. So that'll be the opposite of the original. Your middle term, you're going to multiply, middle multiply, that does stay true. That was the same thing in PSTs. Multiply the two terms of your binomial together. So you can see in these cases, A times B is AB. Again, you don't have to worry about the sign because you already wrote it. It's the opposite of whatever was here. The second sign in the trinomial is always a plus, always positive. And then you square the second term of the binomial. Again, if you, for some reason, like writing it like this, that would be the cube root of the second term, and then you're just going to square it. So you can see that here was the square root of the second term, and you square it, it gives you b squared. All right, there is a little trick that you can use if you want to remember what the signs are going to be, and that is the acronym SOAP. You're always going to have 3 signs total, 1 in the binomial and 2 in the trinomial. So the saying is same, opposite, and the AP stands for always positive. So I actually usually fill out my signs first so that then I don't even have to think about them later. If I use the SOAP acronym, it just goes a little bit quicker. All right, so what I want to look at here, if you were in class, we did part C already in class. We may have done an extra depending on how much time we had in your class. But one that we didn't do was D. So we're going to start with, on the bottom of 269, number 9D. And that's 27 plus 125x cubed. Now, I want to stress again, every factoring problem you need to approach with this order of operations. Always go through this first. So I look at this first, and the first thing I should look for is a GCF. So I would say, okay, 27, it's divisible obviously by 27, but also by 9 and 3. And so I would check to make sure that 125 isn't divisible by 9 and 3, which it's not. So since there is no GCF, next I move on to special products. It can't be a difference of squares, 1 because this isn't a minus. It can't be a PST because it doesn't have 3 terms. So I look to see if it could be a sum of cubes because this is addition. In order to be a sum of cubes, both of these terms have to have perfect cube roots. So you do have a cube root button on your calculator. This button is found under Math, Choice 4. So if you don't know the simple cube roots, first of all, you should learn them. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. If you know those, that's going to cover most of them. In case you would have numbers bigger than that, again, you should know where the button is. Notice both of these are on my list. They're both perfect cubes. So both of these have a perfect cube root, which means it is a sum of cubes. So that means I'm going to follow my pattern. And again, I prefer to go ahead and set up my parentheses, binomial times trinomial, and I prefer to use this acronym and do the signs first. So SOAP, same. So same sign as the original, then opposite sign of the original, and then always positive. And now I'm going to use the rest of this pattern. So first thing I do is take the cube root of the first term. The cube root of 27 is 3, because 3 times 3 times 3 gives you 27. Excuse me. Cube root of 125 is 5. The cube root of x cubed is x. So this is my binomial part. Both the cube roots are filled in. Now, when I go to do the trinomial part, I'm not looking at this. I'm looking at this. So when it says square the first term, it means this one. So 3 squared is 9. Middle multiply. Multiply these together. Gives me 15x. And then my last term, square the second term of my binomial. Be careful. I'm squaring 5x. That means you have to square both parts. 25x squared. So then, because when I'm factoring, I should check to see if it factors further. The trinomial in a difference of cubes will never factor further, so you don't have to look at it. You should check the binomial. I know this one doesn't because it's linear, so it can't factor any further. This is my final answer there. All right, so those are the only parts that are new. So if you were just out of class, this covers the basics. Feel free to stop the recording if you don't feel like you need any extra examples. If you do feel like you want some extra help with factoring, I'm going to do a few more. But they're optional, again, depending on your comfort level. If you are not very good at factoring, I very much encourage you to work through these extra examples with me. So we're going to look on the next page over. So on page 270 is where we're going to look next. And we are going to do all of the parts of number 11 and 12. So number 11, you can just do out in the margin. They want you to write it out as if it's a proof there. Oh, never mind. I thought it was not done in yours. It's done in yours too. I just looked at your version. I thought mine was only filled out because it was the teacher's edition. But no, they already factored it for you. So I guess the only thing we're going to look at there in 11 is I'll just tell you what the steps were that they went through. Because I'm not going to ask you to write out a proof like they have there. But I do want you to understand what they did. In the first step, they wrote 2x outside of x to the fourth plus 3x squared minus 4. So what they've done is the first step in our factoring checklist. They've taken out the GCF because all of these terms were divisible by 2 and all of them had an x. So what was left, again, it's just like when we did long division. What do you multiply 2x by to get 2x to the fifth? You multiply by x to the fourth, so on and so forth. Now, after they did the GCF, they looked to see if this factored further. So I look at this trinomial and I look to see if it could be a special product. It cannot be a difference of squares because it has 3 terms. In order to be a PST, perfect square trinomial, the last term would have to be a plus, and this isn't. So it's not a PST, can't be a sum or difference of cubes, again, because it's a trinomial. So step 3 would be to look at chart factoring. So my leading coefficient is 1, which means that if it chart factors, it should be the easy way where I'm looking for what multiplies to my last term, -4, and adds to my middle coefficient, which is 3. So hopefully you can easily answer what multiplies to -4 and adds to +3. That would be +4 with -1. That means these are my winning numbers. So now the difference, be careful. We're so used to factoring and writing xx. We're higher order polynomial now. X to the fourth we get by x squared times x squared, not x times x. So be careful of that. That's a common mistake. But these winning numbers tell me what to put in the back. +4 and -1. So I chart factored there to get that. So first I did GCF, then I did chart factoring. Then I need to check one of these factors further. This obviously doesn't. This, it's a binomial. So I look, it doesn't have a GCF. It can't be a difference of squares because even though they are perfect squares, this is a plus. It's not a PST because it's a binomial. It's not a sum of cubes because these don't have perfect cube roots. I look at this one. no GCF, so I look for special products. It is a difference of squares. Both x squared and 1 have perfect square roots, and they're separated by minus. So difference of squares, hopefully you know by now. Square root of the first, which is x, plus one place minus the other, square root of the second term, which is 1. And so then x squared plus 4, and then bring down the rest. So last step was difference of squares. So notice we had multiple steps of factoring. You have to keep going until it doesn't factor any further. So let's look at 12a now. We've got x to the fourth plus x squared minus 20. So I go through my checklist. First I look for a GCF. They don't all have x's, and they don't have any common factors. So no to GCF. Next, looking for special products. So in order to be a special product, since it's a trinomial, the only thing I could look for would be PST, but since this is a minus, I know it's not. So I can skip special products. It's not that. So I look for chart factoring. So leading coefficient is 1. So that means I'm just looking for what multiplies to negative 20 and adds to positive 1. So those magic numbers are positive 5 and negative 4. Again, in your chart, feel free to just start listing. I get people I've seen just from helping people that some of you just sit there and think that you can't figure it out. That's not what this chart is supposed to be for. This chart is supposed to be for listing the factors. If you know it on the first try, that's great. But if you don't, you just list all the factors of negative 20. So it could be positive 5, negative 4, positive 10, negative 2, positive 20, negative 1, or they could be switched, negative 5, positive 4. So again, that's the place where you should be listing the factors, not just sitting there until you find the one that works. List them. If you get it on the first try, great. None of the rest of these add to 1, so we know that they're not the winners. These are. So that means I set up my parentheses directly because it was a leading coefficient of 1. Again, this is x to the fourth, which means these should be x squareds. And then my winning numbers, a plus 5 and a minus 4. Again, just because you factored once doesn't mean you're done, especially now that we're dealing with higher exponents. So I look at my x squared plus 5. There is no GCF. I look for special products. Can't be a difference of squares because it's not a minus. Can't be a sum of cubes because these don't have perfect cube roots. I know it's not factoring by grouping because it has to have 4 terms. So nothing further for this guy. This guy over here, no GCF. Special products. They both have perfect square roots and it's a minus. So this also is a difference of squares. So I'll bring down my first one. And now I need to factor this second one as a difference of squares. So square root of the first term, I put in the fronts, which is x. Square root of the last term is 2, so I put that in the back. One gets a plus, one gets a minus. Now I look, these are linear, so they're not going to factor further. I already knew that x squared plus 5 didn't. So this guy is going to be my final answer there. All right, again, if you think you've got it, feel free to stop. You can always come back later if you want to, but I'm just going to do all of the examples while I'm doing a recording. So, 16x to the fourth minus 81 is our first problem. So, look for a GCF. Again, if you don't know factors very well off the top of your head, that's fine. Use your calculator. 16 is divisible by 16, so you might try to divide 81 by 16. It's not. 16 is also divisible by 2 and by 8, so you would see if 81 is divisible by those, which it's not. 16 is also divisible by 4, but 81 also is not. So that means that I do not have a common factor here. So I move to special products next. So it's a binomial, so I need to check both for, oops, I didn't go up quite far enough, difference of squares or sum and difference of cubes. Those are my special products that are binomials. So, in order to be a difference of squares, I would have to have perfect square roots. So, 16 has a perfect square root, x to the fourth has a perfect square root, and so does 81. So yes, it is a difference of squares. So I'm going to make two parentheses. The square root of 16 is 4, so that's going to go in the front. The square root of x to the fourth is x squared. Remember that a square root means what can you multiply times itself to get this? X squared times x squared is x to the fourth. And I know one gets a plus and one gets a minus. The square root of 81 is 9. So now I look at each of them individually to see if they go any further since they're both quadratic. No GCF. And since it's two terms, the only one I would look at is sum of cubes because it has a plus, but no perfect cube roots here. So that one's good. So now I look over here. I need to consider difference of squares or difference of cubes. So I look, do they both have perfect square roots? 4 does, x squared does, 9 does. So this, from a difference of squares, is also a difference of squares. There's no such thing as a sum of squares, so this guy stays. So now I do the exact same pattern that I just did from here to here again. So the square root of 4 is 2. Square root of x squared is x. One gets a plus, one gets a minus. Square root of 9 is 3. Now I know that I'm done because these are linear. And so that's my final answer. Finally, 12C. X minus 2 to the fourth plus 10 x minus 2 squared plus 9. This is very, very similar to the one that you did in your homework the previous night, the one that was in number 2 and 3 on page 267. So if you look back at what we did there, on your paper that you did the homework on, or in your book if you wrote it in your book as well. This one, when I look at it, there is no GCF like there was in the example in the book because this term over here doesn't have an x minus 2. However, the concept is pretty much the same. Because what this is getting you to do, these two problems, is to realize that this itself is a term, and this is a term, and that x minus 2 to the fourth, x minus 2, I could make this a y. This has the same format. You don't have to write this. I'm just using this as an explanation tool. If we were to say that y is x minus 2, then this would take the form y to the fourth plus 10y squared plus 9. And I think that most of you, when you look at this, would see that this factors. So it's just trying to get you to make that connection. Now you can use a substitution. If that makes this easier for you, feel free anytime you know that it's this type to make a substitution. What you can do is to look at this and then say, okay, going through my factoring order of operations. There is no GCF. I check to see if it could be a PST. These both have perfect square roots. So that'd be y squared and 3. The middle term would have to be double their product. So it'd have to be 6y squared, which it's not. So it's not a PST. Close, but not quite. So that means it's going to be chart factoring. So I'd be looking for what multiplies to 9 and adds to 10. Again, there was no number in front, so that's why we're just looking at the 9 and we don't have to do the multiply thing. So multiplies to 9 and adds to 10 would be 9 and 1. So that means, factor this, since this was y squared, I know it's, or since the original was y to the fourth, this is going to be y squared and y squared. My winning numbers were 9 and 1, so plus 9 plus 1. Now the only thing you have to do if you like looking at it like this and you like this substitution that I made is you have to remember to go back and substitute again at the end because this can't be the answer. The original problem doesn't have any y's in it. But if you like this substitution idea, then you can go back and you can substitute again at the end. I'm probably going to use brackets here so I don't have double parentheses. So y was x minus 2. So this is x minus 2 squared plus 9. And this is x minus 2 squared plus 1. Again, if you can see that factors this way just by looking at it and you don't need to make a substitution, that's great, that's fine. You are not required by me to make a substitution. Just writing your chart with the 9, the 1, the 10, and then going from here to here would be perfectly fine with me if that makes sense to you. All right, so there's some extra examples for you if you are struggling. If you still feel like you're struggling, again, please come see me. I'm here after school to help you. Math Lab can help you, but we can certainly provide you with some extra examples if you need them.